Okay. Um, so like I was saying, we this was actually where we stopped yesterday, and then where I was explaining the columns, and then so I selected that of my column reinforcement. So I want to use Y16. I want this software to provide just Y16 for me in my columns. So you are at liberty to choose as many size of reinforcement, but most times it has to do with how many number of stories from your experience. Maybe if you are going up to 3 floors, that's maybe you're having two suspended floors, you may most likely have a Y20 on your ground floor. But what we are designing now is just one suspended floor. So Y16 on the ground and Y16 on the first floor, I think it's actually going to be okay. So you always use your experience and choose the proper reinforcement for your design. That is why it's called design. So you make provision for reinforcement, and the software will analyze, and then if those still reinforcement and then the structural sections are perfectly okay, it will tell you that everything is safe. But anyone that actually fails, you will see it will indicate that it has actually failed. So for my beam here, I'm going to be choosing Y16, and then let's come to slab. I'm going to be using Y12 for my slab. I just want the software to provide just Y12 for me. Okay, so you can choose as many size of reinforcement that you want to select, that you want the software to actually make use of. Okay, so I'm just telling this software not to go outside that size of reinforcement. Okay, that is why I'm choosing those reinforcement. And then for my links, I don't want the software to provide anything more than or less than Y10. So I click on OK. uh, so I'll go to my foundation floor. Here I'm going to provide the reinforcement here. For my foundation, I want it to use just Y12, and then for the links here, I want it to actually make use of Y10. So after doing that, then you can choose the soil property. This is actually from your soil test results. You have to do the soil test. Okay, so that, yes, so there on site. So once you run those tests and analysis on in the lab, so whatever results you get, you can actually feel all of that here. So I click on OK here and click on OK. The next thing here is to come to my project parameter. I'm actually using BS8110. So it's just for me to confirm here. But if I didn't specify my code of practice, I can actually come here and actually change that to whatever practice. You can see they are also here. Uh, so I can switch to whatever code of practice. BS5950 is actually for steel design. You can see for wind load case and all of that. But our design is just reinforced concrete design. So I'll come down to my foundation. This is actually the soil bearing capacity of that site. Okay, so there, whatever soil bearing capacity you get from the lab results is actually what you are going to fix here. So 200 kilonewton per meter square is actually a very good soil. um like in Nigeria, the place I am in Nigeria, I'm in Kaduna State. Okay, in Kaduna State, our soil bearing capacity here is actually very, 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 very strong. It's actually very, very okay. So we use more of pad foundation here in Kaduna, but in Lagos, which is very popular, I believe you must have heard of Lagos. Uh, Lagos, the soil bearing capacity in the island part of Lagos is actually very, very poor. it's usually less than 100. So around those areas, they usually use more of raft foundation and pile because it's actually a waterlogged area. So because our soil bearing capacity here, it's actually very okay, and in this design we are going to be using a pad foundation. So I'm going to be assuming 200 kilonewton per meter square. So even 150 is still very okay. Anything above 100, I think, is slightly okay. It's okay. Yeah. So once you're going less than 100, I think it's becoming a bit poor. Okay, the lateral loading, lateral drifts. Okay, all of this loading, most especially with you are dealing with your wind load and all of that. We'll go into that much more later in the training as we progress. Lateral drifts, as you can see, this our building is definitely going to be braced in both directions, okay, because we are going to be having walls around them. Okay, there will be walls that will be bracing all of these columns, so they are going to be braced. Okay, so the walls are going to serve as a bracing to these columns. Okay, once you are live on site doing your project. Okay, here the title, you type the project's name. Let's say is a proposed, let's say 2 bedroom or 4 bedroom flat, duplex rather. So the name of made by, sorry, you, it's advisable you make this in capital letter, okay. uh that's upper cases. Made by, you can type the engineer, okay, whatever is your name. Checked by whichever engineer is going to check it. Project number, let's say 001, and then the project dates. We are in January now, so you type January 2022, okay, and then we'll click on OK. We'll come to load cases and load and combination. You can remember on your steel design, it was actually giving us one warning that our load cases was actually not loaded then. So so you have to load you have to load this. That's your load combination, and then your load case, and click on OK. So as simple as that, you click on OK. The load combination is the combinations of be subjected on that building. You're going to be having live load, you're going to be having dead load, and all of those load combinations. That is just what it means, times the factor of safety. Okay. We come down to your wind load. Here we are not using a wind load because this building is actually not very, very high. So I'm not considering wind load on this project. So we'll come here to analysis. So sorry, before then, you can do your building model check. Is good you do this building model check here. If you click on this, just click on start. So it will tell you if there be any error in this particular project. Okay, so you can see building model check completed. Number of errors is equal to 0. So that means that there is no any error. Now, these are the list of the possible errors that you're going to have on your project. You can see overlapping slab, overlapping column check, overlapping slab with beam and column walls check, column inside slab panel check. Okay, you can just read through all of this. So these are the possible errors. So but you can see that this model has passed through all of this, and it has checked this model, and then there is none of this error on this project. So it's perfectly okay. We are actually very good to go. Sorry, I actually rerun this just now, so there's no need. So you can see it's 0, so I click on close. So now I can now click on building model analysis. So I'm going to check on column, and I'm going to check on beam reinforcement design. I will ask this software to reselect my bars. Okay, so I run that building model analysis. Okay, it's actually still loading. So it's actually analyzing the building right now. So after this analysis, you're going to see uh, the structural members that actually failed, and those members that actually passed. Okay, so if there's any failure anywhere, it's definitely going to indicate with a red indication. Okay, okay, I think it's perfectly okay now. I'll click on close. It's loading in the background. Okay, it's still loading in the background. Okay, it's done now. uh, okay, I can see it's still loading. It's almost done. All right, I'll go to post analysis here. So on my post analysis, I can check for either column or wall, but there is no wall design on this. So if I click on this here, I'm going to see the list of my columns which I have designed. So you can see that I'm scrolling down. Now everything here is showing green from this design statue here. So that means all our column has actually passed. Okay, so they are very, very much okay. So the next thing here I'm going to do is to check for my beam. So I click on beam reinforcement, and then I'll scroll down. So you can see these are actually all my beams, and everything here is showing green. That means my beam has actually passed as well. So my design is perfectly okay. The only thing I need to check now is for my slab, and then I run my beam, my column. Sorry, I want to check the slab. Then I run my foundation design. That is my footing. Okay, so I'll click on close here. So you can see automatically it has actually popped up an analytical model for us by this side, by Okay, let me drag this by the side here. You can see it here, load combination, everything by this side. Okay. Um, so uh, the next thing I'm going to do here is to run a slab strip. Okay. So what? The slab strip is to actually it's more like you are running the reinforcement on the slab. Are you there? Yeah, so it's like placing a reinforcement on your slab. So once you place those reinforcement on the slab, if it is not sufficient, it will tell you the deflection is actually not sufficient. So you may need to increase the slab thickness, or you change the spacing of your reinforcement, or you change the size of the reinforcement. So there are three different uh, things you can do to make your slab safe. Either you change the depth of the reinforcement, not sorry, depth of the slab, size of reinforcement, or the spacing of the reinforcement. So that's the essence of slab strip. Okay. So this analytical model, I'm going to take it out. Uh, I'll close this. I want this to be larger. So okay. So I'll come back to my model here, and I'll click on slab strip. But one thing you need to know about slab strip is once you are stripping, uh, you are running this strip on your slab. Uh, there are things you have to put into consideration here. You can see we have limit status here, and then because this slab is actually a solid slab, we are using analytical strip. If you click on this drop down here, you're going to see FE strip, we have manual strip. Okay, but since this is a solid slab, so we are using the analytical strip. Okay, when it comes to your raft foundation, your waffle slab and rib slab, we are actually going to be using the FE strip. So we'll go into that much more later as we progress in the training. But here, I'll just click on this point outside, and then I drag. While dragging, in order for you to achieve a straight line on your strip, you hold on control on your keyboard. But another thing I would like to explain is here. Here you can see here you have at start, you have at end. Now, what this means is this. The first one you can see here means this is at start, this is at end. At start, that means you're starting where you are starting from. Okay, you didn't get me? Ah, okay, I'm with you. It's strip. Just click on slab strip. Okay, so once you click on slab strip, this will actually display. This menu will display. So once it displays, this is at start, this is at end. At the start, this means inside a slab. Okay, this actually means in a slab, like inside a slab. Okay, for example, like here, if I'm starting like inside the slab, let me escape this. Let's say I'm stripping from here, I'm starting from here, I'm dragging from here to this end. So if I'm dragging from here, my starting will be this, while this means you are starting from a beam. So if you drag your mouse, it's supposed to even indicate by giving you it's somehow interactive. So if you move your mouse, it should display the name. Okay, so this is for a slab. This is actually for a beam if you are starting from a beam, while this is when you are starting from a cantilever. Okay, so the same thing with the one down here. Slab, you are starting with, you are ending with in a slab, you are ending here with a beam, you are ending here with a cantilever. So in this case now, you can see here we have a beam here we also have a beam. So that means our starting is a beam and it's actually ending at a beam. So I'm clicking on beam for the start and I'm clicking on beam for to end this. You can see the beam are shaded. So if I click here, I'll hold on control and then I drop. So sorry, another point I need to explain is this. You can see that this place is shaded X. That means at horizontal it is X, vertical is Y. So if you are going vertically this way, you have to switch this to Y. Okay, so this is also a beam. This is also a beam. Remember I said this is a staircase area. We assume this to be a staircase. So I'm starting with a beam and I'm ending with a beam. So I'll click here. I'll hold on control in order to achieve a straight line. So if you don't hold on your control, it may not give you a straight line. And the essence of this is telling telling the software how to actually arrange your detail, your reinforcement. Now, if I zoom this, you can see I have a return here. If I also zoom here, you can see I also have a return here. So this reinforcement is actually returned here because this is a beam here. This reinforcement is not supposed to go out. But you can see here, the reinforcement did not return. So that's the main essence of this as well. So here I'm going to switch this to Y direction. But let me show you something briefly. You can see the detailed drawing here. Even though I changed that reinforcement to Y12, but you can see at the detailing here is giving me Y8. Okay, so I can highlight all this strip and delete them, but I'm going to assume that this is what I want for the purpose of this training. But in my Y direction, I'm going to change the size of this reinforcement. So I want to show you how to change the size of reinforcement if you are not pleased with this size of reinforcement and the spacing. So you can actually change the size of reinforcement and the spacing that the software will provide for you. Are you following? All right. So I'll go to my settings. Sorry, this software. Uh, let me look for that setting. Sometimes. Okay. I have. Sure. Okay, exactly. This is what I'm looking for. So if you go under your display, you're going to see display settings. If I click on slab here, you can see it has it like a drop down here. If I click on this, I'll come to rebars. That's reinforcement bars. Okay. Uh, you can see minimum steel bar size from this setting is Y8. Okay. The software try to always make your design safe and economical. So, but it is customary to use Y12 in Nigeria, so I don't use Y8. So, and I'm also going to change this spacing, for example, to 200. So my bar spacing here for minimum bar spacing is 100, maximum bar spacing is 100. So I'm going to make everything 200 because I don't want it to provide different spacing of reinforcement for me. So you are at liberty to play around with the software. That is the essence of being an engineer, is to do your design, make your design safe, and then economical. Okay, so here I have switched to Y direction. This number is showing me 3, so I'm going to drop it down to 1. So I'm starting from Y in my Y direction, from 1 in my Y direction. So just like what we did the other time, we are so lucky with this design that everything is starting with beam and is ending with beam. So there are cases where you have cantilever and all of that. So it's actually good. Most times you start with very simple designs, or else you may keep getting stuck at some levels if you actually design. So it's good you start with it. Good. Now you can see what I have here.
It says slab strip Y3. Okay, slab one, that's story one, slab 3, the deflection check Ly, sorry, the deflection check L over D is equals to 45.25. Is actually greater than 38.85. So the section is insufficient. Yeah, so this is how you know whether your slab has failed or it has passed. Okay, so I click on OK here. What I'm going to do is to uh, rerun this strip here. So along my Y axis, it has failed. So I'm going to delete that strip.
So I just deleted it. So I'll come back to my model. Sorry, I'll go to the settings. Okay, I'll go to the settings here, and I'll click on setting, display setting, and I'll come to my slab here, click on my rebar. You know, like I said, sometimes once your slab fail, it could be the size of reinforcement. Sometimes it could be the spacing of the reinforcement that you need to change. So you can see my size of reinforcement is still Y12. I'm still going to maintain it. But this time around, I'm going to make the spacing 150. And then I'll click on OK. So that's the essence of design. Okay, it's just for you to once you are running your design, you keep trying different sections and spacing until you get one that will actually pass. But sometimes from experience, you already know the spacing that will pass and the reinforcement that will pass. So, but there are rare cases. That is why design is very important in every project. So you don't just use experience. There are exceptional cases. Yeah, there are exceptional cases. I just felt what I actually chose should be okay, but you can see that it has failed around that area. So I hold on control, and then I drop. You can see it has still failed. So what I'm going to do now is to increase the thickness of this panel. Okay. So I will delete that strip again, but this time around I'll highlight on the panel. If I click on that panel, I'll right click and I'll go to properties. Then I'll come here. You can see the depth of this slab is 150. So I'm going to make it 200. Then I'll click on update here. So let me zoom this and see what I have. Let me see if that change has taken effect here. Sorry, the system has actually stopped at a point somehow. Okay, now you can see the depth of this slab now has changed to 200. I don't know if you're seeing it, but it has changed to 200. Can you see it? I want to zoom it, make it more larger.
But system is actually misbehaving somehow.
Oh my God. All right, so the depth has increased to 200. So I'll rerun this strip on it along this y-axis. But you can see the x-axis passed, but the y-axis has failed. So let me strip it again. I'll hold on control. Good. Now you can see that there is no any insufficient notification. So that means this panel is now safe. Okay. Uh, so here I'm going to hold on control. So I think all my panels are now very much safe. So the next thing I will do here is to go down to my slab analysis and design under my design. Okay, so I'll come to slab analysis and design. I'll just click on it. Now you can see I have all stories, but I just have one suspended floor, so there may be no need for me to check this. And then you can select the number of stories you want to analyze. Just for example, if you have multiple stories that you have panels on them. So you can see here reinforcement selection options. Okay, so here the first one is to check design. Maybe you just want to check the design. This one is to check design. But here is in bracket, you can see only reselect insufficient. Reselect all the steel bars that are not sufficient.
Okay. Then the third one here is to delete and reselect all steel bars. So it's going to delete and reselect all the steel bars. So I usually love to make use of this. So if I run that design, and then let's see what it gives us. All right. So this is my report. So my design is perfectly complete. So you can see my slab is sufficient. My slab is sufficient. So you can print this directly and submit to the regulatory body in your country. Attach it to the detailed drawing software will provide for you. So I always like to leave it as PDF. That is why it's good to feel that there is a place if you can remember, I typed in proposed to oh my god, this is blunder. Proposed to 4 duplex, and that's an error. Okay, proposed 4-bedroom duplex. Okay, the date. Okay, so it's good you fill in that place properly. So because it's actually going to display in your report, as you can see here, it has actually reflected here. Okay, so this is our report. You can actually save it as PDF, or you save to Office. Okay, so I always like to make mine PDF. So once you just click on it, that's all. You can save to PDF. I believe you know how to run that. Okay, so we are done with our design as it is. So the only thing I need to include is my my footing. Okay,
So you can see here down here we have report manager here, pre-analysis check, post-analysis check, analysis model. Okay, you can RC beam design. Let's go to RC beam design. The report is not generated yet. Please generate the report before previewing. Okay, so we'll go back to if you go under your sorry, here this drawings and reports, you can see it's here, story beam is here, my foundation beam
is also here, my part base and pile detail is also here. So if I click on story beam, it will take me to beam. But there is another way you can go into that. You know, once you go under your analysis, you go under your building analysis, you can find your beam there, just like what we did earlier. So you can also locate that from there. So I want to believe this is loading in the background, something I can. I think my system is becoming slow. Well, it's not even the main challenge. The main thing is the processor and then the RAM.
No, this particular system I'm using, this one I'm using for you right now, I'm using to do this is actually not very high. So what? An external? Okay. All right. Thank you for that. Yeah, I'll try. I'll try. Of course, I will. I will try. Okay. 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 Yeah, exactly. I'll do that. Now you can see after clicking on my beam elevation, my beam detailing just displayed. This is for, you can see ST1, that is for story 1. The ST2, if I shift this, you can see beam elevation ST2, that's for story 2. Okay, yeah, so you can just click on it and zoom to see the detailed drawing from here, even before taking it to your prota detail. That's what we call prota detail. I'm going to take you through that briefly. So you can see these are your beam details for your story 2. That is your roof beam. This is for floor beam. So you can as well zoom this. This we are using what I'm doing. I want to shift this. All right, but I believe the message is clear. Let me just go down to where we can. Oh my God, this thing is really obstructing me. Okay. All right. if I come down to um, back to my plan, I want to view my reports for my beams and that of my column as well. So I'll go to building analysis. So I'll go. So mind you, this same step
Can you can actually do that same. You can see you have your report here too as well.
I always like to run it from here. I don't know why, because it's actually the same thing. So um, so if you come to design reports, I can include all of this, but I'm going to leave it as it is. So, but look at the something. Let me show you something that happened just now. It's actually preparing the reports.
Okay, now you can see this design status, the colors has actually changed. What this means not up to date. Okay, to make this turn green, I have to go back there and rerun the analysis again. Okay, so that is why those colors have changed. But you can see that indication is not a red indication. Okay, it's not telling you that it has failed. It has just changed. Okay, so but that is not a red indicator. So but you can see this is our reports now for my column, the same way with that of my beam. Is just to click on PDF or click on Microsoft Word, or you can click on print to print directs to your document. Okay, so I'll close that. I always like to make mine in PDF, so you can do as well. So that of beam, that of column, that of slab and column. I think I have gone through the analysis, and then you can see the detailed drawing there. Yeah, you can see the analysis results are not up to date. So that is why you can see that indication actually changed. So the right thing to do is to, okay, so I'm not going to go through that process. It's just for you to click on analysis, and that is all. Since we have done our model, we have checked. So you can see here is just to click on design reports, and then your report here will be displayed. Just click on OK. So the same thing with all your structural members. You convert them to PDF, and then you print them or convert them to whatever format you feel is actually convenient for you. The Microsoft Word, like Word document, is good, most especially when you want to do some little editing on your reports. So you may want to edit some little something there, and then you use the Microsoft Word to view your reports. But I usually make mine in PDF directly and I print. So just make sure that your work is perfectly okay. You can make it in PDF and print. Okay. So it's preparing the report. So by Monday we are actually going to love to go into the foundation today, but I have actually spent a lot of time, and then time is of essence. Things to actually catch up with. So by Monday we are actually going to go into the foundation, and then I will take you into Prota detail, where you are going to see all of our things in our Prota detail. As it is right now, it has already provided our detailed drawings already. Okay, our detailed drawings in this software is already very much available. It's just for us to in our Prota detail, and your Prota, it has some tools that are common. I think they are shortcut keys that make the same with that of AutoCAD. So if you are AutoCAD environment, I think you will have issues with the shortcut keys as regards to Prota detail. You can see this is actually taking very, very slow right now. So out of our column and the way it did as well. So you don't see what?